So linear differential equation. In this lecture, we will see definition of linear differential equation. So first of all, what is linear differential equation? Means which differential equation is called as linear. An equation of the form dy by dx plus p into y equal to q is called as linear differential equation. If you see, this is the first term of the LHS, that is dy by dx, that is a derivative of y with respect to x. Plus sign is compulsory. If you will get minus sign here, then you have to write plus sign and adjust that minus sign with the second term. Since in the first term the derivative of y has been taken, therefore we need in the second term y variable, and the coefficient of this y is denoted by p. Keep in mind, this p must be a function of either x only or it may be constant, but it never be a function of y. The right hand side is again a function of x only or maybe constant, but it is not a function of y. So such a type of equation is called as linear differential equation. See the another equation and try to analyze what actual happening in such a linear differential equations. So the equation is dx by dy plus px equal to qy. In the first term, the derivative of x has been taken. Therefore, in the second term, there must be a variable x, and the coefficient of x is denoted by p. And now this p will be a function of y only, or it may be a constant. And the right hand side is again a function of y only, or it may be a constant. So this is also a linear differential equation. So let us see the theoretical part. Derive solution of the linear differential equation dy by dx plus p into y equal to qx. So to derive the solution, we have to find such a factor. If we multiply the left hand side of the given differential equation, then the left hand side will become a perfect derivative, and such a factor is called as an integrating factor. So first target is to find such an integrating factor for this given differential equation. For this purpose, we consider dy by dx plus p into y is equal to 0, and let me call this expression is an equation number 1. So now we will use method of separation of variables. So using the method of separation of variables, we get dy by y is equal to minus px dx. The meaning of the separation of variable means you reshuffle the terms in such a way that you will get in the left hand side an expression of y variable only, and in the right hand side the expression of x variable only. So that's why we have separated x variable in the right side and y variables in the left side. Now we will take integration of both sides. In the left hand side, the denominator is y, and the derivative of y is 1, which is present in the numerator. And we know that the rule of integration, when the derivative of the denominator present in the numerator, then its integration is nothing but log of denominator. So here denominator is y, Therefore, after taking integration, we'll get log of y is equal to minus integration p dx plus constant of integration. Usually, we are taking c as a constant of integration, but in the left hand side, already we have got the answer in terms of log y, and that's why, for the sake of simplicity, we are taking here in constant of integration as log of c instead of c. Now this log of c transferred to the left side, and we know the property of log, that is log a minus log b is equal to log of a by b, and using that property we'll get log of y upon c is equal to integration minus p dx. Now take the reciprocal of this y by c, and this will do for the purpose of to eliminate this minus sign. So that's why log of c upon y is equal to integration p dx. Now eliminate the log from the left hand side. Therefore c upon y is equal to e to the power integration p dx. Therefore the value of c is equal to y into e to the power integration p dx. Now we are taking the derivative on both sides. Therefore the left hand side is a constant, therefore its derivative will become 0, and the right hand side is nothing but d by dx of y into e to the power integration p dx. So using the product rule, we are getting 0 is equal to y. You know what is the product rule? First function derivative into second function as it is plus first function as it is into derivative of second function. So the next step is 0 is equal to dy by dx e to the power integration px dx plus y into, here we have found derivative of the exponential function. The rule of finding the derivative of exponential function is you keep exponential function as it is into derivative of the function which is present in the power, that is d by dx of integration of p dx. So therefore 0 is equal to dy by dx e to the power integration p dx plus y into e to the power p dx into px. Here the integration and the derivative both are reversible, therefore they may get cancelled, and we have got px only. And therefore finally we'll get 0 is equal to e to the power integration px dx, which we have taken common, and inside the bracket we are getting dy by dx plus pxy. Keep in mind this bracketed quantity is nothing but the left hand side of the equation number 1. That means if you multiply by this factor, this one e to the power integration p dx, this right hand side is a perfect derivative of y into e to the power p dx. So therefore when this factor e to the power integration p dx multiply to LHS of equation 1, then LHS of 1 will become perfect derivative of y into e to the power integration p dx. That's why this factor is called as integrating factor, and it is denoted by IF. Now multiplying this integrating factor to equation 1, we get e to the power integration p dx into dy by dx plus py is equal to again this integrating factor into q. Therefore due to this integrating factor, this LHS will become a perfect derivative of y into e to the power p dx, and the right hand side keep as it is. Now integrating both sides, we know that integration and the derivative are reversible process. Therefore integration and this d by dx will get cancelled out, and therefore we are getting y into e to the power integration p dx is equal to integration of whole right hand side and again plus c, that is c is a constant of integration, and this is nothing but required solution of given linear differential equation. So using this we have completed the proof of this theorem number 1. Now let us see some examples of linear differential equations. The first example is solve x square plus 1 into dy by dx plus 2xy equal to 4x square. So write the solution. First of all, write the given differential equation. So you write as it is, x square plus 1 into dy by dx plus 2xy equal to 4x square. Now dividing by x square plus 1, we get, why we are dividing x square plus 1? Because for the linear differential equation, the coefficient of this differential coefficient dy by dx must be 1. So it is not a 1. Therefore, to getting the coefficient 1, we are dividing by x square plus 1. Therefore, we will get dy by dx plus 2xy divided by x square plus 1 is equal to 4x square divided by x square plus 1. See, the first term is dy by dx. The y variable is present here. Therefore, the coefficient of y is 2x upon x square plus 1 is nothing but our p, and the right hand side, which is a function of x only, this is our q. So this is a linear differential equation, and equating with original differential equation, we have got the value of p and q. Now using the value of p, we have to find integrating factor. So first write the definition of integrating factor is equal to e to the power integration p dx. Put the value of p inside the integration, that is e to the power integration 2x upon x square plus 1 dx. We know the derivative of x square plus 1 is 2x, which is present in the numerator. Therefore, the value of this integration is log of the denominator, and the denominator is x square plus 1. Therefore, integrating factor is equal to e to the power log of x square plus 1. The log and e both are having base same, and therefore e and log get cancelled out, and therefore integrating factor is equal to nothing but x square plus 1. Now using this integrating factor, we move to find the general solution of the given differential equation. So ask the question to this equation, whose derivative has been taken here, and the answer is the derivative of y with respect to has been taken. Therefore, while writing the general solution, you first write y into integrating factor is equal to integration q into integrating factor plus c. Now we know that integrating factor is x square plus 1. Put this value, we'll get y into x square plus 1 is equal to integration of q into x square plus 1 dx plus c. The value of q is 4x square upon x square plus 1. When we put the value of q here, the x square plus 1 and x square plus 1 get cancelled, and we get in the right hand side integration of 4x square dx plus c. Now how to find the integration of this x square? The x is having index power 2, therefore we can use the rule of power of integration, and that rule is add 1 in the power, so the power will become 3, and again divide by the same 3, and therefore the final answer is y into x square plus 1 is equal to 4x cube upon 3 plus constant of integration c, and this is our required solution. Now using this tempo, we'll solve another example, example number 2, cos square x dy by dx. So keep in mind here we have made a mistake. I have written dx by dx, but actually it is dy by dx. You read this as a dy by dx plus y equal to tan x. Now let us find the solution. As usual, alright, the given differential equation is cos square x dy by dx plus y equal to tan x. the coefficient of dy by dx is not 1, it is a cos square x. To get the coefficient 1, dividing both sides by cos square x, we get dy by dx plus y upon cos square x is equal to tan x upon cos square x. From the trigonometry, we know that 1 upon cos x is a sec x. Therefore, the next step is dy by dx plus sec square x into y equal to tan x. So instead of 1 upon cos square x, we have written sec square x. Okay, so this is a linear differential equation, and the coefficient of y is a sec square x, and it is nothing but our p, and this right hand side is a function of x, and this is nothing but our q. So therefore p is equal to sec square x and q is equal to tan x into sec square x. So using this p, now let us find the integrating factor for this example. So formula of integrating factor is e to the power integration px dx. Put the value of p inside the integration, that is nothing but sec square x. Therefore we know the integration of sec square x is tan x, and hence we got integrating factor is equal to e to the power tan x. Now let us find the general solution. Therefore required solution is in the example we know that the derivative of y has been taken. Therefore you write y as it is into integrating factor is equal to integration q into integrating factor dx. Just put the value of integrating factor instead of if, you will get such expression. Now the only problem is how to solve the integration of right hand side. If you observe in the right hand side, here is the exponential function, and the power of e is tan x, and मतलब डेरिवेट मतलब इंटीग्रेशन ऑफ एक्सपोनेंशियल फंक्शन तभी निकलेगा जब e के सर पे ऐसा फंक्शन रहेगा जिसका डेरिवेटिव कांस्टेंट आता होगा. लेकिन e के सर पे क्योंकि tan x है और उसका डेरिवेटिव sec square x आता है, so we cannot find the integration. So this is the main problem, and that's why to eliminate that problem we have to put t equal to tan x. But whether my thinking is right that I'm putting t equal to tan x, so there is a criteria to check whether you are correct or not correct. So if you want to put t equal to tan x, so just check the derivative of this tan x whether it is multiplied to this dx or not, and here the sec square x, which is a derivative of tan x, is multiplying dx. Therefore we can put t equal to tan x. Therefore put t equal to tan x, therefore derivative of tan x into dx is nothing but dt. Therefore sec square x dx is equal to dt, and therefore the right hand side of the above equation will become integration t into e raised to t dt. Now in this integration there is a product of two functions. One is a t, that is called as an algebraic function, and another function is e raised to t, that is exponential function. So it is a product, that's why we want to solve this integration by using by part. So we are using the rule of by part here. The first function is algebraic, that's why we have a shortcut to solve the by part, that is draw the first two bracket minus another two brackets. In first bracket you put this first function as it is, in the second bracket you put the integration of this e raised to t, and integration of e raised to t is again minus now take a derivative of this t and put here in the first bracket, and again you take the integration of e raised to t and put in the second bracket. So this is the value of integration. Therefore while taking e raised to t as a common, we are getting e raised to t into t minus 1. Now back substituting the value of t, we are getting the required solution, and hence the required solution is y into e to the power tan x is equal to e to the power tan x into tan x minus 1 plus c. Now, using the help of these two examples and the theory part, the students can able to solve the following examples. So let us take homework. The first example is dy by dx plus y is equal to e to the power minus x. Second example is x plus 1 into dy by dx minus ny equal to e raised to x into x plus 1 raised to n plus 1. And the last third example is x into dy by dx minus ay is equal to x plus 1 upon x.